So for section 5.4, we're going to be looking at the definite integral. So what we've been looking at so far is the indefinite integral. So what we're actually going to do, instead of finding a function after we integrate, we're actually going to be finding a constant. So the theorem is if a function is continuous on a closed interval a to b, then f is integrable on that closed interval a to b as well. And the net area a between the graph of f and the interval ab is defined as the area under the curve from your x values from a to b. So notice now your definite integral has what we call an upper bound and a lower bound of f of x dx. So some theorems about our definite integral. As long as a is in the domain of f, if your upper bound and lower bound are equal to one another, then we would say your integral from f of x dx is equal to 0. So what we can also say that if you have an integral from a to b that's defined as a lower bound from b to a, especially if your lower bound is greater than your upper bound, you can negate it and interchange your upper bound with your lower bound by negating the integral. So some rules for your definite integral. So suppose again you have your definite integral and you have a constant multiplied by f of x, just like we did with the indefinite integral. You can pull your constant out, integrate from your definite integral a to b, f of x dx. So you can pull your constant multiple rule applies for the definite integral as well as your indefinite integral. If you're trying to integrate a definite integral of a sum, you can break this up and you can integrate your definite integral term by term. And evaluate the upper and lower bound for each of the f of x and add it to g of x. This also applies for subtraction. So again, I can integrate from a to b of f of x dx, subtract the integral from a to b g of x dx. So these three rules apply for both your indefinite and definite integral. So if you have f that's integrable on a closed interval containing 3 points, a, b, and c, then if you are trying to integrate from a to b, you can split this up at some point between a and b from a to c of f of x dx, add it from that same point c to b of f of x dx, regardless of how the points are ordered. So again, you can split up your integral and add them together at some point between the curve.